C2, exponentials and logarithms, example 13. So this is an exam question. You can see the whole question is worth 6 marks, so you want to be spending sort of 5 to 6 minutes on this question. In part A, we've got to solve an equation where we want to find out the power. To be able to do that, this is why we take logs. So we need to log both sides first of all. Then when we've done that, using one of our laws of logs, we know that we can bring that power then to the front. So to work out x, we've just got log 7 divided by log 5. Now it asks us to give that to 3 significant figures, so if you can work that out on your calculator, you'll get 1.21, and that's to 3 SF. In part B, we've got to solve an equation, and you'll notice that the powers, our x terms are in our powers, and you need to recognise with a question like this that it's going to be a quadratic. And the more questions you try like this, the more familiar you'll be. Now that 5, we can rewrite that as 5 to the power x all to the power 2, because we know from one of our C2 rules that if we've got x to the power a b, we can write that as x to the power a b. So 5 to the power 2x is the same as 5 to the x all to the power 2. The reason we do this is because it's going to be easier for you to spot what you would use for your substitution. So at the moment it looks a bit complicated, but if we use a substitution and if we let that 5 to the power x equal y, then we would have y squared minus 12y plus 35 equal to 0, and we've just got a quadratic equation which you'll be really familiar with solving by factorising. If it does factorise, in this case it will factorise, so 35 we can use 5 and 7, 5 multiplied by 7 to give 35, but we want minus 12y, so we're going to have minus 5y minus 7y, which would give us our minus 12y, and minus 5 times minus 7 would give us a 35. So we've got y equals 5 and y equals 7. But if we look at the question, there were no y's in the original question. We want to solve to find out what x is. So remember, we used a substitution. We used a substitution to make it easier to deal with. So y was actually 5 to the power x. So we need to replace that y at the end with 5 to the power x. Now this one, you'll probably just spot that x has got to be 1. So that's one of our solutions. As 5 to the power 1 is equal to 5. In this one, if you notice, we've already done this in part A, so we've already worked it out by taking logs on both sides to find out what x is, and x was 1.21. So because it was a quadratic, we ended up with 2 solutions. X is 1 and x is 1.21.